Well, it has been a bit since I've demoed some new stuff for the Volatus application framework, and at this point, full-blown test application framework. And there's been a lot of features going in for debugging and development tooling. So let's go ahead and get these demos running. There's not going to be very much visible initially, but this is now running. And so I think I've shown this off before. There's a GUI manager window now. And now all windows will be listed in here. Anything that's using the GUI mechanisms that are part of the framework will show up in this list. So we can see system status. This shows us connected nodes. So when things connect to the TCP messaging server, we'd see them listed, can compare their app versions, their config versions, all of that fun stuff. In the case of console GUI applications where multiple operators will be running the same node configuration, we'll also see their host name here and their IP address. Helps differentiate what systems software is running on. Additionally, now there's a debug GUI. This has been super helpful in debugging applications, and now I can turn on metrics and see loop rates, so I can get an idea if loop rates are what I expect or not what I expect. Like logging manager, yes, that's supposed to spin at 1 hertz, and that is damn near right at 1 hertz, so that's pretty good. Definitely quite dense here in the information, and some types of modules can be a little misleading in their work percentage value, like digital control shows 92%. That's because the timing on this happens via the timed loop that it's running in instead of pending on queued messages. So this looks high, but it's actually pretty low usage on this. And if we look at the bottom here, so I'm going to collapse those metrics just so the list is a little tidier. If we look at the bottom, when we're running in the development environment, even at runtime actually, if you put some extra debugging information on the module front panel, you'd get access to it. Now, in the development environment, this is fine. I can hit Control E, bring open the block diagram, but there are some things that the menu is hidden. And when I have the GUI manager open, I can hit Control E to my heart's content, but unhappily, the block diagram never shows. But when we're running in the development environment, I can Control double click to show the block diagram. So I could double click the GUI manager, it switched me to the GUI manager, but if I Control double click, I can get the block diagram even when the menu isn't visible. So now, depending on how I have sub VI set up and all of that, is there anything in here? Yeah, if I wanted to start debugging in here, I could come into this sub VI and look at the reentrant items and see what's happening in all of this. But now I have access in the development environment to poke at just about every single bit of code that's running under this application. So let's go ahead. I'm going to open up the system status GUI and we'll get the client application running. So we can see it connected. So here's my computer name, here's what IP I'm on, some version information. And now with this being a GUI application, there's a bunch more stuff here. I can open the actual GUI. This is just kind of my scratch pad for testing and demoing some stuff. I believe we looked at the gauge indicators in the past, but as I develop features, I'll test them out in here. But this is, of course, sending commands to the DAC application, the SIM application. It's simulating with some simulated CDAC modules, as well as it's got some software variables configured that are driving these gauge indicators that I can dynamically adjust at runtime and all of that fun stuff. But we can see here in the GUI manager now, it shows you the running status of plugin GUIs. Eventually, I'll roll that out to all of the GUIs so you can more easily know which ones are open and closed. Now, this system status I did open from the DAC application, but I can also open it from the client application, and it also gets the list. So in a larger test system let's say for a rocket engine test stand or a structural test system or vacuum chamber thruster test system, there's typically going to be a couple of operators connected. And sometimes you might be getting errors reported that there's a configuration that's out of sync somewhere in the system. And it can sometimes be difficult to know whose station that is, since any of the console apps would have the same node name, same application name. But knowing what the host name is for that system can make it really easily to say, oh, hey, you've got to pull updated configs. So any connected client would get published to all connected clients that are interested in that information. It doesn't get sent to every node. CRIOs, the DAC systems, the embedded control components, those aren't going to care about connected client lists unless you want them to. Maybe you add some feature where there's interlocks based on what systems are connected or not. Uh, Certainly that's a possibility, and then it would just be add one thing into the config, and that application starts getting that information published to it. What else? So yeah, we'll notice that while this has been running, the warning count has been increasing. Another feature that's available now is system health monitoring. So there is a module running in the background that is checking for free disk space. If I look at the configuration for this setup, where is the system health? So in the system health, I have it monitoring my C drive and my D drive. And if the free space gets below 120 gigabytes, it starts generating warnings. If it ever gets below 80 gigabytes, it'll start throwing errors. And we're actually getting kind of close to that. So maybe if I just run a log for a little bit, we'd see this start changing to an error. But now makes it easy to recognize that systems are running out of storage space, and you're at risk of applications not behaving correctly or data logs failing and losing test data. So these are all, of course, configurable in that config file. But let's say I go in, I deal with that issue. Uh, if it's a CRIO, I remote in and clear up some space on the SD card or whatever I'm using for storage. You resolve that, you can clear the counts, and now start fresh with those counts, close the event GUI, and come back in when things are showing numbers again. Let's go ahead and run a log, just so I can see if I can start triggering those errors. So now everything is logging, including am I running this at 10 kilohertz, 50 kilohertz? I forget. But we should start seeing that show up. Also, there has been a lot more debugging information added in. So during startup, there's a lot more history of what modules are entering what states. And this coincides with the debug GUI, which actually, now that I'm connected, so I just opened this on the GUI application, but we can see both applications and can even get all of the metrics for the embedded systems from your GUI system. So as you're commissioning or debugging application issues, you'd get access to all of this information, even on a remote system. But I can see how my local modules are doing, all that fun stuff. At 80 gigabytes. Oh, 79.9. Hey, look, an error showed up. So let's turn off the debug. Let's go back up to the top. I need to make this automatically scroll up to the top. So now we were getting warnings once every 30 seconds-ish. Now the errors produce roughly every 10 seconds to really emphasize that, hey, you've set a low limit on what you want your free space to be. You should probably deal with that ASAP. So let's go ahead and turn the logging off. And yeah, these errors are going to keep coming in. But yeah, so just a lot of debuggability has been showing up, which has helped me optimize performance, recognize which modules are need some attention, and there's going to be a bunch more features coming in the near future.